Imagine for a moment that everything, every galaxy, every star, every atom, once existed in a space smaller than a single proton. Then, in less than a fraction of a second, the universe expanded faster than the speed of light. This is not science fiction. It's one of the most radical and beautiful ideas in modern physics: cosmic inflation. Today, we're going to journey through the mysteries of cosmology, the evidence for inflation, and what it tells us about the ultimate origin of reality. Buckle up, because this is the story of how everything began. Before we get too deep into this topic, be sure to like this video and subscribe to the channel. This helps to bring more valuable content to the platform for your knowledge and understanding. Remember, knowledge is power. Now back to the episode. Cosmology is the science of the universe as a whole. It asks the biggest possible questions. Where did the universe come from? How is it structured? Where is it going? For most of human history, these questions belong to philosophy or religion. But in the last century, physics has given us tools to approach them scientifically. Einstein's general relativity, published in 1915, gave us a new way to think about space and time, not as a static backdrop, but as a flexible fabric that bends, stretches, and evolves. Out of Einstein's equations came the possibility that the universe itself is expanding. And in 1929, Edwin Hubble confirmed it. Galaxies were rushing away from us, carried on the current of cosmic expansion. This discovery transformed cosmology forever. If space is expanding now, then rewinding the clock means the universe was once smaller, denser, and hotter. Push far enough back, and you reach what we call the Big Bang, the moment the universe began. But here's the twist. The Big Bang wasn't an explosion of matter into empty space. It was the expansion of space itself. Every point of the cosmos was compressed into a tiny, unimaginably hot state, and then expanded. Yet the Big Bang theory on its own leaves us with puzzles. Why is the universe so smooth and uniform across vast distances? Why is space so flat instead of wildly curved? And where did the seeds for galaxies come from? These questions set the stage for the bold idea of cosmic inflation. In the early 1980s, physicist Alan Guth proposed a daring solution: inflation. According to this theory, in the first trillionth of a trillionth of a trillionth of a second, the universe underwent a sudden burst of expansion. Space itself ballooned by a factor so large it's almost impossible to imagine, like inflating a grain of sand to the size of the observable universe. This brief moment of inflation solved the great mysteries. Smoothness. Regions of space that were once in contact got stretched far apart, explaining why distant parts of the cosmos look so similar. Flatness. Any initial curvature of space was ironed out, just as the surface of a balloon looks flat when it's blown up. Seeds of structure. Tiny quantum fluctuations in the fabric of space were magnified during inflation, becoming the blueprints for galaxies and clusters of galaxies. In other words, quantum physics and cosmology met at the very birth of everything. So how do we know inflation happened? After all, we can't rewind the universe on a giant cosmic movie reel. The strongest evidence comes from the cosmic microwave background, the afterglow of the Big Bang. Discovered in 1965, this faint radiation bathes the entire universe, a whisper from 13.8 billion years ago. When satellites like COBE, WMAP, and Planck mapped this glow, they found tiny ripples, exactly the kind of patterns inflation predicts. Those ripples match the seeds of galaxies we see today. Inflation doesn't just explain what we see, it predicts it with eerie accuracy. Inflation may also open the door to one of the most mind-bending ideas in all of science: the multiverse. If inflation can happen once, perhaps it can happen many times. Different regions of space could inflate into separate bubble universes, each with its own physical laws. This is speculative, yes, but it might explain why our universe seems so finely tuned for life. Maybe we live in one bubble among countless others, and in most of them, life would be impossible. Whether true or not, inflation forces us to expand our imagination beyond a single cosmos. We've come a long way in just a century, from thinking the Milky Way was the entire universe to contemplating infinite multiverses. But the quest isn't over. Cosmologists are building new telescopes to probe the faintest echoes of inflation, such as the elusive B-mode polarization in the cosmic microwave background, a subtle pattern left by gravitational waves from the universe's first moments. If detected, it would be like hearing the heartbeat of creation itself. At its core, cosmic inflation is more than a scientific theory. It's a reminder of the extraordinary power of human curiosity. With mathematics and observation, we've reached back almost to the beginning of time. The story of inflation shows that our universe is not just vast. It's dynamic, creative, and deeply strange. It connects the smallest scales of quantum fluctuations to the largest scales of cosmic structure. And perhaps, most importantly, it reminds us that we are part of this unfolding mystery. We are made of the same quantum seeds that inflation magnified into galaxies, stars, and eventually, the molecules of life. So the next time you look up at the night sky, remember, those stars are not just distant points of light. They are the echoes of a universe that once inflated from almost nothing. Sparks of a cosmic story that began 13.8 billion years ago and continues through you. If you found this content helpful, don't forget to hit that like button and subscribe to the channel for more deep dives into the strange and mysterious world of quantum physics. Leave me a comment. I'd love to hear your thoughts on the ever-expanding universe. This is cosmology, this is cosmic inflation, and this is the story of everything.